Hello everyone, welcome to my channel. In this video, we are going to solve a problem which came in 2016 JAM Biotechnology paper. Before going to the question, I have a special announcement for you. If you are preparing for IIT JAM 2021, then you must be doing your B.Sc right now. You study a lot but become confused if you are prepared for your university exams, college exams or not, right? So here Unacademy brings for you free MCQ test series. You can see 50 questions in 90 minutes time you have to solve, and the dates are 11th and 25th March 2021 at 2 p.m. And this test series is totally free. Then what are you waiting for? Enroll for free right now because 11th March is just tomorrow. Okay, so enroll for free quickly. You can also subscribe to Plus classes on Unacademy using my code PHYSJAM-570. I am repeating the code PHYSJAM-570 for 10% discount. If you use this code, you can get 10% discount for the Plus class subscription. Okay, so let's go back to our question. So here the question is, a copper wire having a cross-sectional area of 6.62 into 10 to the power minus 6 meter square carries a current of 20 ampere. Assuming that each atom contributes one free electron to the current, the time required by electrons to travel a distance of 1 meter is dash minute. And given is density of copper equal 8.92 gram per centimeter cube and molar mass equal 63.5 gram per mole. Avogadro number equals 6.02 into 10 to the power 23. Okay, so first let us take a copper wire, okay, whose cross-sectional area is 6.62 into 10 to the power minus 6 meter square. So this area is, suppose A, where A equal 6.62 into 10 to the power minus 6 meter square. Okay, next is the current flow. Current is 20 ampere. So in this copper wire, current is flowing so let's take it as I, and the cross sectional area is A. Okay, so I equal 20 ampere. Okay, now the question says, assuming that each atom contributes one free electron. Each atom contributes one free electron to the current. Okay, so we can say that the number of free electrons is equal to the number of atoms in the wire, okay, as we have drawn here. So let us take it as small n. Okay, say small n. Now we know that the charge of electron is E, or we can take it as Q. Q is suppose the charge of electron. Charge of electron, 1 electron, right? That is equal to 1.6 into 10 to the power minus 19 coulomb. We know this value. We know this value, right? Now, let the time required by the electrons to travel the distance of 1 meter is, suppose, t minute. Okay, let t is the required time. Okay, so t is the time required. Then we can write I is the current flow, right? The flow of current. So current flow, amount of current flow is equal total charge by total time or unit time. Okay, that is total charge per unit time or total charge by total time is equal total charge. The charge of one electron is Q. Okay, that means charge of n electrons is nq, right? Because we have considered the number of atoms as small n, and that is the number of free electrons, right? So nq is the total charge divided by total time is t, right? So I equal nq by t. We get I equal nq by t. Remember, this is small n. Okay. Now next given is density of copper 8.92 gram per centimeter cube. So density of copper, let us take it as rho. So rho equal 8.92 gram per centimeter cube. Okay, we can write this as 8.92 into 10 to the power minus 3 by 10 to the power minus 6 kg per meter cube. Why? Because we know 1 kg is equal 1000 gram or 1 gram equal 10 to the power minus 3 kg, right? And similarly 1 centimeter is equal 10 to the power minus 2 meter, or 1 centimeter cube is equal 10 to the power minus 2 cube meter, that is equal 10 to the power minus 6 meter. Okay, so putting these values, we get it as 8.92 into 10 to the power plus 3 kg per meter cube. That is, we have converted gram per centimeter cube or gram per cc to kg per meter cube. Why? Because you can see here all the units given are in SI, that is in meter, kg. Okay, but only density of copper is in CGS unit, and also our molar mass is gram per mole, so that is also in CGS unit. So we need to convert it also. Okay, now let us take molar mass as capital M, small m. Okay, this is molar mass. So molar mass equals 63.5 gram per mole, or we can write it as 63.5 into 10 to the power minus 3 kg per mole. That is 1 mole has 1 mole has mass 63.5 into 10 to the power minus 3 kg. Okay, now another given quantity is Avogadro number, that is 6.02 into 10 to the power 23, that is Na. Na equals 6.02 into 10 to the power 23. Okay, these are the given quantities. Now Let us calculate the mass of one atom, that is small m. Let small m be the mass of single atom. See here, the mass of one mole of atoms is given as 63.5 into 10 to the power minus 3 kg, and in 1 mole the number of atoms is 6.02 into 10 to the power 23. That is the Avogadro number, right? Avogadro number is the number of atoms present in 1 mole, right? So we can write that 1 mole contains any number of atoms, right? And the mass of that is 63.5 into 10 to the power minus 3 kg, right? So what would be the mass of one atom? Mass of one atom would be 63.5 into 10 to the power minus 3 divided by Na kg, right? So this would be equal to m, because we have considered small m as the mass of single atom, mass of one atom. So m is equal 63.5 into 10 to the power minus 3 by Na kg. Okay, now next, see here. Okay, next is we know rho equal m by v. Now what is rho? Rho is the density of copper, right? Density of copper, rho equal 8.92 into 10 to the power 3 kg per meter cube. So this is the density of copper. Now density of copper, density is equal mass per unit volume. So if this is the volume of the copper wire, okay, so how can we calculate the volume of the copper wire? It is cross-sectional area times the distance, right? The length of the copper wire. Here we need the length to be the distance traveled by the electrons, right? So the distance here is 1 meter. So the length here is 1 meter. So length times the cross-sectional area is our volume. So volume is equal to A times D. If D is 1 meter, then we can write V equal A into D, right? So V equal AD equal 6.62 into 10 to the power minus 6 into 1 meter cube, right? That is equal 6.62 into 10 to the power minus 6 meter cube. This is the volume. Okay. Now let's go back to our formula, rho equal m by v. What is m? So we have calculated v, that is the volume of the copper wire. What is m? M is the mass of the copper wire. Now how to calculate the mass of the copper wire? Mass of the copper wire is the total mass of the atoms. Now we have calculated the mass of a single atom, right? We have calculated the mass of the single atom, that is m. here we have calculated mass of single atom, that is m, and we have the total number of atoms to be n. Okay, so the total mass of the copper wire is n into m. Okay, number of atoms into mass of a single atom, right? So this is the total mass divided by volume, right? So we get rho equal nm by v, or we can write it as n equal rho v by m. Okay, n equal rho v by m, that is number of atoms equal rho v by m, or we can say number of electrons equal rho v by m, right? Now we had this formula, that is I equal nq by t, from where we need to from here we need to calculate t, right? The time we require, the required time we need to calculate. So t equal we get nq by I. Okay, t equal nq by I. So from here we can write if t equal nq by I, then n is rho v by m into q by I, right? So let us now put the values for each. So rho here is, see, rho here is 8.92 into 10 cube, 8.92 into 10 cube, into v here is 6.62 into 10 to the power minus 6, 6.62 into 10 to the power minus 6, into q here is 1.6 into 10 to the power minus 19 coulomb, 1.6 into 10 to the power minus 19 coulomb. Okay, divided by m here is 63.5 into 10 to the power minus 3 divided by Na. What is Na? See here, Na is 6.02 into 10 to the power 23. So 6.023 into 10 to the power 23. This is Na. Into I. What is I? I is given as 20 ampere. So I is 20. So let us simplify it. It is 8.92 into 6.62 into 1.6. If we take this 6.02, this is in the denominator of the denominator, right? So it will go up, that is 6.02. Okay, divided by this is 63.5 into 20. Okay, so here it is into 10 to the power plus 3 minus 6 minus 19. It is plus 23, and when minus 3 goes up, it becomes plus 3. Okay, so if we calculate all these, let's see what we get. If we calculate all of these, we get 8.92 into 6.62 into 1.6. into 6.02 divided by 63.5 divided by 20. So it gives us 0.4478 approximately into 10 to the power. Let's see what we get. It is plus 3 minus 6 minus 19, that is it becomes minus 25, and it is minus 25 and plus 29. Okay, that is equal 4478 approximately. Actually it was 44785 here. Okay, so we can write 4478.5. okay, so this thing becomes so, because here 0.44785, that is 4 places after decimal, and it is 10 to the power minus 25 plus 29, that is we will get 10 to the power plus 4, right? So we are shifting the decimal 4 places. So 4478.5, and the unit would be in seconds. Okay, 4478.5 second. Now we need to convert this second into minute. Why? Because our question was in minute. What was the minute? Okay, so we need to divide this by 60, right? And our answer would be 74.6 minute. Okay, you can do it again. 4.7. Yeah, it is 74.6 minute. So our answer is 74.6 minute. Okay, so we have solved this problem. If you have further doubt regarding this solution, you can tell me in the comment section. I would happy to explain it to you again. If you like this video, please click on the like button, share this video with your friends, and don't forget to subscribe our channel if you are a new viewer today. Ta-ta!